Good evening, everybody. Welcome to February edition of the Triangle Area SQL Server User Group's Advanced DBA subgroup. So tonight, Hasan is going to talk to us about working with SQL Server on a Raspberry Pi. Before we get to that, one quick announcement. So, as people who watch Shop Talk know, Mike Christensen is our newest board member. He has taken over for Tom Norman, who has gone to browner pastures. I think technically where he's at in Texas would be not quite as green as in North Carolina, but we wish Tom the best, and hopefully we'll be able to see him at some event someday in the future. In the meantime, Mike has taken over for Tom's role, and we're getting him up to speed. So TriPass is at a full board, and we'll be able to have a designated survivor once again. So with that, I'm going to hand it off to Hasan. So please take it away.
Thank you, Kim. Thank you for having me today. I'm going to share my screen real quick here. And I'm going to speak about the new Azure SQL Edge with you today. And I had some adventure to actually install this on my Raspberry Pi this year. So I'm going to actually try to explain you how I did it. And it's not really that, I guess, simple. We used to just have CDs and DVDs. You just put in the disk drive and you install it. But with the SQL Edge, really, you kind of need to touch in many technologies to actually be able to install the SQL Edge. So here's our agenda. What I'm going to try to actually try to do here is I'm going to try to cover, I'm going to try to explain what is IoT is, and I'm going to try to give you some stats so we will kind of understand what maybe Microsoft is trying to maybe establish here with SQL Edge and the potential we have with IoT devices. And then we are going to touch to many technologies. I just talk about, for example, Azure IoT Hub. You are going to need. We need to look at the Linux. We are going to need to look at other technologies like containers. You are going to need that. So we are not going to cover every corner of every technology here, but I'm just going to cover only whatever at least you need to know to be able to install the SQL Edge. So let's start because we have a lot to cover here. Before I start, let me speak about myself. I am a Microsoft Data Platform MVP for 2 years, and I'm from Cleveland, Ohio. Currently, I am working at Progressive Insurance as Business Intelligence Manager, and I have some good experience with web development. In last 7-8 years, I have been with the Progressive Insurance and I'm in the business intelligence, so I had some good experience with data. Also, you can follow me in any of those platforms. If you will have any questions about this talk, please just reach me and I will be happy to answer you. Also, I have a blog out there. You can look at it. I like to write about the data, front end, C#, whatever I know. I like to share that. So let's jump in and look at actually our presentation. Let's look at first of all the history of IoT. IoT actually came up with like many other great, I guess, ideas. It came up in 70s, 80s, and they called that connected drive or connected machines then. But the problem was, it was a great idea, but unfortunately, we did not have enough technology to make it actually happen. We had to wait for some turn points to actually happen, so we can actually have this idea in real time or real life. The first thing we had to wait was the CPUs. The CPUs were very expensive, 70s, 80s, 90s. I remember I used to have 286, 386, and they were really cheap, and they were not really that fast. So we had to wait, I would say probably 2010s, 2010s. The CPU prices, start to go down, and you were able to actually buy the CPUs cheaper. Also, we had to wait for communication. So the communication, we had to wait for the Wi-Fi to be a common style to communicate. And really, we are still looking at 2010. Wi-Fi actually became a common communication way. But the last turn point that actually we had to wait was the IPv6 upgrade. The main reason for that was, well, IPv4 did not have enough IP addresses for all those IoT devices and other internet addresses. So in 2011, there was a big turning point for IoT when the IPv6 came. As you can see, you can have many addresses you can have for potential any kind of IoT devices. So if you look at the history, the first IoT device was actually a clock machine. It was in 1982, and one university, the students actually connected this clock machine to the local network, and they put a sensor in it, and that sensor was just checking if how cold actually the drinks was. So that was the whole thing, and it was connected device. After that, we see 1990, our friend John Romkey connected this toaster to the internet by using the TCP/IP. And he was actually able to control how well done was the bread. So he was actually able to change the time. He was very excited, and things were going good. 1991, the first webcam came, and again, another university. That's the University of, I believe, Cambridge. So the students were kind of tired because every time they go to drink coffee, well, the coffee machine was empty. So they tried to come up with a solution for that. They connected this camera to the network, and they made it actually take picture every, I don't know, maybe 1, 5, or 10 minutes. And after that, they were able to actually see if they needed coffee. So with that, they came up with the first web camera in 1991. Then 2000 comes up. And in 2000, LG actually spent a good amount of time and money on this connected refrigerator. This refrigerator is pretty complex for that time. You could make video calls. It was able to kind of watch inside, and there was cameras inside, and you can see what you need. And you can have a couple of applications with that. And it was connected to the internet. And you can see that actually it was on the 6th day. You can see Arnold out there. They were kind of marketing it there. So it didn't work. The main reason it didn't work was, well, it was $20,000, and it was very expensive. And also, who's going to need a video call in 2000 by using the refrigerator? So, I mean, it was great, but it was not really that useful. And it's in the history, it failed. So, if we try to explain what IoT is, really, we have like a one main board, and you put a couple of sensors depending what you are trying to solve, and those sensors just sense the data, and they get the main board gets all these sensors and just send it somewhere, right? So that somewhere that creates a lot of possibilities for many type of businesses. There are a lot of type of IoT devices. Some of them are useful, some of them are really useless. So in the left side here, for example, we have those health watches. I have one here, which kind of checks your heart and all kind of blood pressure and other stuff. So it's useful. And it kind of gives you a report. We have those speakers. You can kind of talk to them. They will play the music you like to play, and they kind of know you. They kind of suggest stuff to you. Or we have those outlets. You can control them. So there are some useful stuff, and people are actually using it. The right side, though, there are a lot of useless stuff too. So, for example, that fork they call it smart fork, and it's connected with Bluetooth to your phone. And if you are eating too fast, that thing actually shakes and lights up, and it gives you some report. I don't know if I eat what, that's the last thing I really need when I'm eating my food. Or other thing, they call that the smart, I think, server. And depending what's really happening around you, it kind of changes what's really in front of you, and it just prints something. So those are the stuff that I can actually share here. There's even like other stuff that I cannot even show you, but like for example, adult industry is going crazy, and they are kind of sharing all kind of data that probably they shouldn't. So there's a lot of useful and useless IoT devices out there. And if you look at some of the actual stats here, as I said before, 2011 was the turn point for IoT devices because of the IP addresses, IPv6. And this chart actually shows you how IoT devices actually going crazy. So there is growth in IoT devices. In 2020, you might not be able to see here, but this number is 50 billion devices. Not million, it's billion. And that's a crazy number. If I try to explain that to you in a different chart, look at this one. In 2020, we don't have even 8 billion human on Earth, but we have 50 billion connected devices. That makes 6.58 per person. This really doesn't represent the right data because we know that not every country has internet or any kind of like technology. So that number is much higher if you're actually looking at the people who has the technology. It's kind of scary number, honestly. It's almost like a Skynet out there, right? It's getting ready. They're connected. They have 50 billion devices. That's crazy. Also, if you look at like what kind of devices we have, is really most of the people has a smartphone. Smartphone is probably the most common IoT device out there right now that many people has. And it generates all kind of data and it shares that data. Well, who knows what. And sometimes we are looking for something online and next thing on the TV you see the commercial, right? So there's all kind of stuff going on in the back end. If we look at the large scale users of IoT devices, we have smart cities. Most of the big cities now, well, computers are really in charge of when the lights are going to come up and when the things needs to get clean. And they watch from the videos or the cameras and they learn. And that applies to, for example, the cars. You can actually request the car and the car can come up and pick you up. And that needs a lot of data. And that needs to process a lot of data, and it needs to share a lot of data. So a lot of stuff is happening with IoT with the large scale users and technologies. As I said before, one of the other turn point for IoT devices was the connections, which is the Wi-Fi was needed, required for IoT actually to kind of became common. So those are the common IoT connections that you are going to need for your IoT devices. The perfect network connectivity option will be probably like it will consume extremely little power. It will have a huge range, and it will be able to transmit large amount of data, right? But unfortunately, that does not exist. So those are the options we have. The first one is cell phones, right? Or the satellites. So for that, you're going to need a high power consumption. That's the main reason you have to go and actually charge your phone daily. It has a high range and it has a high bandwidth. So those are great, but the problem with that one is expensive. The second option you have is the connections with the low power. It has a low range, but it can send the data fast. And those are the Wi-Fi and Bluetooth. So those are probably the most common ones, right? I can say because they're cheaper and they are very common. The last one is the LPWAN, which is the low power wide area network. This one is actually requires minimum power. It has a high range and it has a low bandwidth. So if you are maybe like sharing data, for example, in agriculture, they are kind of watching how the temperature of the soil, right? And that doesn't really change that much. And they can actually use the LPWAN devices for those, and they'll be able to actually make it really cheap, very affordable to actually create those IoT devices, and you can reach them from from distance. So those are the options you are going to have for IoT devices. But we have some other problems with IoT devices, which is the security issues. The main problem for that one is, well, you have I just explained we have like 50 billion of them. So usually what companies do is they just put the default, password in it and they don't really change it. Everything is hard coded. They just don't have time to go back and change those again and again. And sometimes those devices are not strong enough, right? So they cannot really, even you want it, they might not be able to, actually give you encryption or any kind of like strong advanced security features. So those are the challenges for sure for the IoT, any IoT devices. That's where Azure IoT Hub comes in. So if you think about it, if you're going to actually have IoT devices for your business, depending how many, I guess, instruments or how many devices you're going to have, you don't want all those devices to start to report back to you, like on-prem databases, because you don't know how many you have and how many you might have in future. So scaling is going to be a problem, and there's going to be a lot of, I guess, responsibility. So it's much easier to give that responsibility to a cloud provider like Azure, and Azure has it. It just manages everything for you, and everything is hosted in cloud. Just like another features they have is scalable. So if today you have 100 IoT devices, and next year you're going to have 10,000, Azure IoT Hub can actually do that for you very easily. This is the place. It's a central hub. All of your IoT devices are going to connect to IoT Hub, and they're going to send the data. In the meantime, you're going to be able to send them back the messages if you need to change settings or if you need to do any kind of upgrades. Azure IoT Hub is going to be the place for you to actually communicate with all your IoT devices. And it's reliable and secure since you are dealing with Azure. They have some requirements out there for IoT devices to have. So that kind of gives you some kind of peace on top of that. So when you say that it's scalable, and you need to kind of pay for the per the messages. So right now, for example, we have two tiers here: basic tier and standard tier. What I pick on this one, which I'm going to show you here, is the free. As you can see, I can send 8,000 messages per day for free, and there's a message size here. It cannot be more than that. So depending what type of, I guess, solution you are trying to create, you kind of need to look at here and pick one of those here and start to kind of pay for it. So that's how you're going to be able to scale up or scale down in Azure IoT Hub. But Azure doesn't stop there. So, okay, you send the message from your IoT device to Azure Hub. Then what, right? So there are some options out there that you can actually take that message and move it to another Azure product. So for example, those are some of the examples we have. You can use the Azure Event Script, and that kind of enables your business to react quickly to critical events in reliable and secure manner. The second one is logic apps. It's almost like kind of reminds me of the SSIS packages, really, but it just automates your business process. And you can actually do the machine learning, and that will just add the machine learning to your AI models. And you can kind of learn from IoT devices and maybe do something or change something. And stream analytics, it just runs real-time analytics computations on the data streaming from your device. So you can do it like real time, if you like. There is another term here. So we just talked about the Azure IoT Hub. There is another one, Azure IoT Hub, Edge. They call it mostly edge computing. So what is edge computing? As I said before, in Azure IoT Hub, you have the IoT device, and it just sends constantly, like, I don't know, maybe every 30 seconds, every 1 minute, it just sends this data to IoT Hub, right? In IoT Hub Edge, the idea is, okay, maybe we don't need to send those data every 30 seconds or every, like 1 minute, right? So we can maybe give IoT Hub device a little bit more responsibility, and maybe it can actually store some of that data out there, and it will be more, I guess, responsive. Right? Because if you are gonna, for example, you are driving a car, right, and there's another car coming up front of you, and you send a message to IoT Hub, and IoT Hub is gonna send back to you and what to do. Well, you have a network problem out there. If there's something that happens out there, your car doesn't know what to do because it just doesn't have that, I guess, the answer from the IoT. So in here, when you put this in IoT Edge, actually device is most of the devices are actually more, I guess, complex and more powerful. So you can actually install applications in them like Azure SQL Edge, for example. So they can actually keep some of those messages and learn from them with the machine learning services. And they will be more reliable because, well, if you are going to lose your connection, guess what? Maybe your application will be okay because it knows how to handle itself for some time. And also, all the applications that I just said, those are for, you are going to need the containers. So all of the applications will be in containers, and you will push them from the Azure IoT Hub Edge to your device. Now, we are kind of ready to, I guess, introduce the Azure SQL Edge. So we have some kind of idea what we kind of, I guess, have to do. So the first thing we need to know about Azure SQL Edge currently is the SQL Server 2019 on Linux version. If you look at the specifications of SQL Edge, it doesn't really say SQL Server 2019, it just says latest of SQL Server. So today is the SQL Server 2019. And Microsoft recommends you to have Ubuntu 18.04 in your device if you want to use this in production. But it doesn't come up with all features of SQL Server 2019. It comes up only with the database engine only. So you don't have SSIS package, SSRS, or SSAS, any of those things, you don't have it. You just have the data, not even all the database engine. For example, you don't have, for example, memory, in-memory tables. You don't have file tables. So there are other things that you are kind of missing. You are going to need a 64-bit processor. And that processor can be x64 or ARM64, which is interesting because ARM64 brings us that we can actually install this to Raspberry Pi. It's going to require at least one CPU and 1 gig memory. When Azure SQL Edge actually fires up first time with doing absolutely nothing, the footprint is 450 megabytes. So depending, I guess, what you are going to try to do with it, you might, I will recommend at least, since the memory is cheap, I will recommend like at least 4 gig. But in the meantime, if you are going to have like 1,000, 10,000, thousands of IoT devices, you might want to watch for that too, for the price. As I said before, it doesn't come up with all the features of other SQL Server functions. But it comes up with this 3 other stuff that none of the other SQL Server versions has. The first one is SQL streaming. That is, which is based on the same engine that powers the Azure Stream Analytics, and it provides real-time data streaming capabilities. So when the data comes to Azure SQL Edge, it can actually send to IoT. Data bucket is a T-SQL function that other SQL servers versions doesn't have. And there to act actually machine learning capabilities through the Onyx runtime that's in the SQL engine too. So you can kind of learn from what's really happening in the device. And pricing is another kind of common question for that. So if you want to do pay as you go, is let's say just $10 per device and per month. If you want to have a reserved option, it will be $100 for 1 year, and it will be $60 for 3 years. So 3 years makes sense if you have some kind of like long-term solution or long-term if you are trying to do something long-term. But I mean that looks cheap, right? It doesn't look that expensive. If you go pay as you go, they're talking like $120 per month. But it's just per device. So if you have thousands of devices, IoT devices, that will get expensive very easily. So watch for that one. And also the billing starts when actually you deploy the Azure SQL Edge to your device the first time. So if it's not even running, they will still keep you charging for that. Now, Azure SQL Edge works like a pacifier. right? So I use this one more likely. IoT devices are like babies. Babies like to cry, and IoT devices like to send something and send the data. And as I show you in the IoT hub, that happens constantly. So SQL Edge actually works as a pacifier. And what happens here is you put the pacifier in, and IoT device is still there, but still it makes it happy because it doesn't need to send all the data to IoT hub constantly. And it can actually think and it can actually do something without getting some feedback from the IoT hub or another script that running out there. So you can actually be happy. We have two versions of SQL Edge. The first one is the SQL Edge developer, which I have, and that one supports a 32 gig RAM, and it goes up to four cores. The production one actually goes up to 64 gig, and it can support the 8 cores. Now, let's talk about how we are going to actually install Azure SQL Edge to our IoT device. First of all, we are going to need IoT Edge runtime. This is the application which makes your IoT device an IoT Edge ready device. It installs and updates all the workloads that you are going to need from IoT Hub. It's going to have all the communication. It's going to report the health of your device, if anything is running, everything is you're going to be able to see in IoT Hub Edge. All the communication is going to get managed by it. Security is going to be with it. And you're going to be able to, as I said before, we're going to have containers. So you're going to be able to send a container from IoT Hub Edge to your device, and Edge runtime is going to actually handle all those things in the middle. To do that, it actually uses two modules. The first module is the IoT Edge agent. That one is for initiating the module. So if you're actually, for example, send the SQL Edge, IoT Edge agent is going to see that. It's going to download it, and it's going to start it for you. And it's going to report if there's anything wrong with it. You are going to be able to see all the results, as you can see all the results that it supports out there in Azure IoT Hub Edge. The other one, the module we have is the IoT Edge Hub. So that's almost the same IoT Hub, but it's in your device. It's a proxy. And it's just reporting the status, and it's just responsible for the communication between your device and the Azure IoT Hub. When we receive a Raspberry Pi, actually that's the time that I took this picture. So as you can see, it came with all kind of boxes. And I was very excited, and I thought, okay, I'm going to jump in this and start doing and connecting SQL Edge is going to be really easy. Unfortunately, it wasn't that easy. I had to learn all those technologies. But here are the specifications of this device. As you can see, it's decent. I think I spent on this like maybe $50, maybe $60, and that's it. As you can see, we have RAM, and when I bought it, it was 4 gig RAM. I got that one. I have Wi-Fi, and I have 2 USB ports. I have, which is impressive, I have 2 HDMI ports, so I can connect 2 actually HDMI monitors on this thing. And you can connect cameras, you can connect display ports. It has all kind of sensor boards if you can go. So for $50, $60, this thing is great. And it came up with the Debian Linux version. So I was ready to just jump in and actually start install the SQL Edge on it. Right? That's what I thought. It didn't work like that. First of all, to actually be able to connect to this device, if you want, you can put the HDMI cable on it and just have one monitor for it. But I just didn't want to kind of, waste one monitor on that. So I want to be able to connect that thing from my Windows machine. So to do that, there are some third-party tools out there you can download, and you can remote into any kind of Linux device. But many people not realize one thing, that actually the OpenSSH, which is the application I use, is available in Windows itself. So you don't really need to download anything. We are going to use the SSH to remote in any kind of Linux drive. And here we are going to do the Raspberry Pi. So to do that, we are going to need to go to PowerShell and open your PowerShell, and you can actually use the add Windows capabilities, right? And open SSH.client. This will actually enable SSH remote tool in Windows. Second one here, I'm just showing you just to know that the server is out there too. You don't really need it, but I enable it out there here too. So what I did here is I just add an SSH tool in Windows. Next, what we need to do is, well, okay, we have the application. Now we have to make it, I guess, ready and start it. The start and service SSHD is going to actually start the application, so you can actually start using it. But we want to actually probably make that startup every time the computer starts. So that's what I'm doing here. I'm just saying set service, and SSHD is the name of it, and automatically it's going to start every time the computer starts. After that, you might want to check if firewall is actually blocking it or not. So by this one, you can actually see if it's getting blocked or not. By just doing that, you have the SSH application ready. It will be fired up every time you run the computer, start the computer, and you will be ready to actually connect to your IoT device. In my case, Raspberry Pi. So to connect it, all I have to do is I just need to say SSH and give the IP address. By giving the name here, that's the username, and I'm going to actually try to connect this IP address with this username. And as you can see, it asks the password, and then I'm in with the Raspberry Pi. So all the comments that I'm going to write here is going to actually run in Raspberry Pi, and I'm still in Windows, so I'm happy. I'm not really like a Linux guy anyway, so I had to learn all kind of commands, how to install stuff. So this kind of helped me. At least the environment is, I can still see the windows or my, I guess, monitor, so I was happy. Now, before we go and actually look at some of the comments I'm going to show you, I just want to remind you one thing, because that was a mistake I made in many times when I was trying to install this. So many, other applications, you really don't need to worry about this architecture. Now we have two types of CPU we need to worry about. So in my case, I have ARM64. So everything I want to actually install for Raspberry Pi has to respect to this architecture. You cannot just, all of the applications out there, especially in Linux, there's like 10 or 20 versions of them. And at the end of the kind of visible file, it just says that this file is for this architecture, this file is for this architecture. So you kind of need to, I guess, know what kind of architecture, CPU architecture you have, so you can download the right files and install them. I'm saying that because when you pick the wrong one, well, it really doesn't say that, oh, this architecture doesn't match with the CPU. It just throws all kind of weird error that you kind of get frustrated, and it's not easy to figure out really what's happening. It doesn't say that, oh, you know what, this is the wrong file. All right, so now, so far, we know what IoT devices are. We are able to remote in a device. Now, we are going to actually go back to Microsoft website and start to see how are we going to actually install this Azure SQL Edge. The first thing you're going to know is SQL Edge is in a container, and we need to push it from the IoT hub. And there's going to be a lot of, I guess, things to read about there. But I guess the most important part, which I didn't really see, was there are two types of supporting systems in Microsoft. One is the tier 1, and the other one is tier 2. If your operation system is in tier 1, you're good. That means you are actually using something that Microsoft suggests, like Ubuntu 16.04, Ubuntu 18.04. Those are supported fully, and Microsoft gives you all the information how to do this. But on the other hand, Ubuntu 16.04 and Ubuntu 18.04 is not the latest versions of Linux, Ubuntu version. So I think right now they are working 21 or 22, something like that. And even before that, there's a 20.04. So the first thing I did, as I said, my Raspberry Pi came up with a Debian Linux version. So, and I see that Microsoft actually suggests the Ubuntu. I said, okay, you know what? I'm gonna go get the Ubuntu. When I went to Ubuntu's website, it's pretty easy. You just download the version, and it just gives you you have to flash the drive and put it back in the Raspberry Pi, and you are good to go. And the problem is, when it listed the versions to me, I was like, well, why don't I get the latest version? Why do I need to go to the early version, right? So I get to 20.04. I didn't know about this tier 1 and tier 2 support. It just says Ubuntu out there, right? So I just download that. So because of that, I was not in tier 1 support. As you can see, Ubuntu 16.04 and 18.04, they are supporting fully. I was in this one, tier 2 support. What they're really saying here is all of the stuff you see here, they will work with no problem, but they are not giving you any kind of manual how to install the SQL Edge, really, especially that runtime to your device. So I'm in this list. I have Ubuntu 20.04. So that's why it took a little bit more time for me to, I guess, figure out how to do this. I'm glad I did it because I learned a lot. So that's something to kind of watch. So if you are gonna download it, and if you don't want kind of headache, you might just kind of go with Ubuntu 16.04 or 18.04 for a easy, I guess, install. Now, let's say we have Ubuntu Server 16.04. Right? So what actually Microsoft suggests here is they have this packages website. And you can actually go and look at all the devices here. You can check the folders. And all of these comments I'm going to show you is on the Microsoft documentation. So what we are doing here is first we are going to get the repository that actually Microsoft gives us. In that repository, software repository, they are actually providing all the file locations, and it's in this prot.list file. And I'm using this C URL, which is name is the client URL, and you are able to actually download from internet with this command. That's in Linux. And I'm going to this website here and getting this file, and I am moving that file to my local folder and changing the name to Microsoft prot list. This Microsoft prot list actually has all the repositories that Microsoft provides me for tier 1 support. Then I am running this command. Sudo means run as admin in Windows. In Linux, it means do as a super user. So I'm doing a copy as an admin. I am taking the file that I just downloaded, and I am moving to sources.list.d. That's the Linux internal location for repositories, software repositories. So I'm just adding this list from Microsoft to my local Linux repositories locations. That's all I'm doing here. The next thing I need to do, I need to worry about my security because Azure has some security things for devices to connect. So in here, I am again going to this website here and downloading this the file with the C URL. And then I am copying that to trusted GPGD. That's a Linux, again, location for trusted websites. So that's all I'm doing. And this one actually applies to tier 1 or tier 2. It won't give you any kind of problem if you're in tier 1 or tier 2. And it applies to both of them. So in my case, Ubuntu 20.04, I still need to do this. Then next, as I said before, we need to deal with containers. And then, well, we need a container system in our Linux drive, Linux in Raspberry Pi. And that applies to tier 1 and tier 2 is exactly the same way. And we are using the Mobi engine here. And Mobi engine is just like it's a container system. And you're going to be able to kind of, I guess, specialize this engine for your need, rather than using a Docker or anything like that. Mobi engine, you can customize everything. And also it's open source. So that's probably one of the main reasons that they pick it. And we need to install this Mobi engine to our, well, in my case, the Raspberry Pi. So what I'm doing here is I'm using apt-get, which is application package tool. And what I'm doing is just updating my local repositories here first. Then I'm getting the latest version of the Mobi engine, and it goes and downloads it for me and installs it for me. And then I'm going to actually change and actually download some of the files from here to configure my Mobi engine. And then I'm changing the permissions of this file, the one that I just get. Then I just run it. This one applies to tier 1 and tier 2. So it doesn't matter which operation systems you have, you need to do this one for sure. Now, we need to install IoT Edge, which is the runtime, which is going to actually be, I guess, get configured for Azure IoT Hub. So this is the part that is going to install all the information from Azure, all the application it needs. To do that, this is only for tier 1. So if you have Ubuntu 16.04, 18.04, that's all you have to do and you are good to go. So what you are doing here is you are just, this is the application get, you are just updating your current repository. And that repository, I'm talking about the Microsoft we just download from. Then you're going to be able to use this apt-get install IoT Edge. And your Linux is going to know where this IoT Edge is because Microsoft supports it. And you just got that repository from Microsoft. And you're going to be done. That's going to be it for you. If you are looking at different specific IoT Edge, you can kind of still use and change the reference numbers here if you like, the version numbers, and you can download earlier version if you like. But still, this works only for tier 1. And your Linux knows what IoT Edge is because Microsoft defined it right here in this file. So after that point, you are good to go. Your IoT Edge is ready, and I will show you how to configure that. But before we go there, if you don't have Ubuntu 16.04, you're in trouble because when you actually type this one, your Linux is not going to know what IoT Edge is because there is no file from Microsoft which tells us how we should get this IoT Edge file. To do that, first thing we are going to need is we need to look at the dependencies of IoT Edge. And the main dependency of IoT Edge is SSL. And SSL is required. And this reference file, we need to download first. And that's one of the main dependencies of IoT Edge. So I will share this presentation with you and you can actually look at that. But this is the location of this file. And the main reason this doesn't work in 20.04 is, well, as you can see, this is the SSL 1.0.0. That file did not change. That was a core reference file of Ubuntu 16.04 and 18.04. But when the next version comes up, this one is actually upgraded to 1.1. So it's not there anymore. And in the newer versions of Ubuntu. So you have to actually go find this file and download it first and install it first before you are able to get the IoT Edge. And as I said before, architecture is important. And you can see all those architectures at the end of the file. This is the same file, but they are for different CPUs. So depending what CPU you have, you just need to pick the right one here. So that's going to be the first one. How do we do that? We are still going to use a CURL, and we are going to just put our URL here. And I'm just taking this file, and I'm naming it as test.deb. Deb are, I guess we can compare the zip files. So you have to depackage them first. And to depackage it, you need to use the dpkg. And I'm saying I here, and I'm just giving the file name. This is going to depackage the file. Then I can actually install it by using the apt-get install and libssl, the 1.0 version. As soon as I have this run and completed, I'm good to go. I'm good to go, but now where's the IoT Edge? Because I don't know where it's located. So now I have to go and find the IoT Edge. IoT Edge actually is in the GitHub, and you can go, it's open source, you can see it, and you can get the latest version. So that's what I exactly did the same way. I downloaded from here, and I run it with the apt-get install IoT Edge. And in this case, it didn't give me any problems because I had what is required, which is the libSSL file. When this is completed, if everything goes fine and everything is processed, the only one thing is going to be left after this, that we have to register our IoT, in my case, the Raspberry Pi to IoT Hub, so I can actually see my connection string. So to register your device, you have three options, which I'm going to show you Azure portal here, but you can do by the VS Code. You have to download the IoT Tools extension for that. Or you can do the Azure CLI. You still need the IoT extension for that. I listed my items with VS Code. I've never tried to register it, so I don't really have that much experience on them, but it looks pretty easy. I did everything from the Azure portal. So when it comes to registering your device, you need to, I guess, figure out how to get your connection to actually authenticate to your Azure IoT Hub. You have two options. One is the symmetric key authentication, which is really the connection. They give you a connection key. You just take it and put it in your file. It's almost like a connection string. This is great, especially if you are testing stuff, but it's not recommending for production. For production, they recommend you to get a certificate of authentication, and you have to that will instantly take a little bit longer to actually get, but that's what they actually recommend for production. Now, to register a device, we have to go to Azure IoT Hub, and we have to create the Azure IoT Hub workplace first. That's pretty easy. It's just going to ask you what do you want to call the name. You're going to pick a region probably and your subscription, and that's it. Really, there's nothing special on that. So it's pretty easy to create an IoT Hub for you. To register a device, then you are going to go in your IoT Hub, and from here, you are going to go and look at the Azure IoT Edge devices in the left side, right here. Then this page is going to come up. You're going to click on Add an IoT Edge device. Then we are going to have a window comes up, and it asks you some very simple questions. You are just going to give a name for your device. And here's the place that I was talking about, how we are going to connecting to Azure IoT Hub. So I'm going to keep symmetric key, and as you can see, the rest is really easy. Just it can connect, and if the keys here are going to be auto-generated, or you want to give the keys yourself. So I'm just keeping as default here. And then this is completed. I called my Raspberry Pi Rasp 4. Since I picked the symmetric key, now I can come here and get the connection string from here. When you click here, you should be able to see this from here and copy this one. Then we are going to go back to our Linux command line, and we are going to go and type this super user, do it as a super user, nano. What is nano? Well, nano is the notepad, really, notepad of Linux. And we are opening this file by using Notepad. And in this file, you need to go and find the connection string line and paste what you got from the IoT Hub to here. After that, you just save your file. Then we are going to run this command, which is going to restart the IoT Edge. And also, it's going to run it every time your application, in my case, Raspberry Pi comes up online. And after that, you can look at the status of IoT Edge. So when you run this, you should have two modules, and status should be running. So here what it looks like when I run them. The first one restarts IoT Edge runtime. The second one just checks, as you can see, it just checks all of my connections. It's checking if it can connect to the Azure IoT Hub here, and everything check marked. So I'm happy it's actually connect. That doesn't mean that I have the Azure SQL Edge yet. So what I have so far is I have my device. It can connect to Azure. It can connect to Azure IoT Hub. They can communicate each other. And that's it. That's all I have so far. Now, I'm ready to actually install SQL Edge to this device. How do we do that? Again, I'm going to go back to Azure IoT Hub, since I said that, all the modules needs to get pushed from Azure IoT Edge to my device. So I'm going to go back and find my device here, as you can see. And I'm going to actually click this set modules icon. When I click that, we are going to have some options here. So where this module is going to come from? In here, I'm going to pick the marketplace module because Azure SQL Edge is a marketplace module, and you don't really need to do that much. But you can, create your own modules and push your devices too. So that's why you have different options here. So under the modules, I click Add. I pick the marketplace module, and then I need to search. I just search by SQL. As you can see, the top two is first one is the developer version. Other one is the production version. So I picked the Azure SQL Edge developer. And then we had to do a little bit more configuration. As if you have experience with the containers, that's what before you run the, I guess, the SQL Server, you kind of need to at least give like a SA password, and you need to be, agree with the EUL and other stuff. So those are actually under the environment variables, and you kind of need to at least give the SA password here. And when you actually complete this, what's going to actually happen here is Azure IoT Hub is going to change I think it's a JSON configuration, send it to your IoT device because it knows that we just registered it. It knows where it is. Then your Raspberry Pi is going to actually download SQL Edge and push this configuration on it. And when it's completed, it might take time depending how much your network connections and your device. When it's completed, you are going to actually you can use the IoT Edge list. This one actually lists all the containers running in IoT Edge. As you can see, I have here Azure SQL Edge running, and that time this is the latest version I was running. So it took, I'll say for my device, maybe 15, 20 minutes to be able to run this, because what happened is I tried before and I forget to actually give a SA password, so it couldn't connect. So I had to come back here and actually give a password, then it started to run. And some common problems I had, sometimes my first one, the Debian Linux version, was my CPU 64-bit, but my operation system was 32-bit. So I was still downloading the SQL Edge, but it didn't want to kind of work because, well, my environment was not right. So you get all kind of different errors like that. But in here, I was able to actually run it. So now let's actually see. I will show you. Let's try to connect it. It's actually running right now. So let me see here very quick. Let's run the ssms. Now let's go connect database engine. That's the IP address of my Raspberry Pi SA, and that's the actual password I just passed in Azure IoT Hub. When I connect, as you can see, it's connected. SQL Server 15, which is the SQL Server 2019. Everything is working fine. Let's try to, I guess, can create a new database. Let's say sensors. So really I guess next step here, I have my SQL Edge working here. Now, really my next thing I want to do here is maybe create like a very custom .NET Core application and push it here and start to push data in here. So that's going to be my really next, I guess, thing to do. I haven't started yet because I needed some break after this. So if I actually let's do this. So as you can see, I just created a database in Raspberry Pi, and I can create people. Yep. So I have my tables, I have my everything, and everything is working just as it is, really. But don't forget, you have only the database engine here. You don't have all those other kind of features. To get the list, you can look at the Microsoft website. They have a great kind of documentation on that. So as you can see, we were able to connect. And really, that was my adventure I wanted to share with you today. I hope everybody learned something new. There was a lot of technologies I had to kind of cover. And again, if you will have any questions, if you will have any kind of problems running this, just please connect me from any of those platforms. And thanks again, Kevin, for inviting me and giving me a platform to speak.
Of course. Thanks for your time tonight, Hasan. So we do have a few questions, and
Sure.
I've been having conversations in chat as well, but absolutely want to get your takes on this. First, how does Azure SQL Edge compare or differ to SQLite?
So I think SQL, honestly, I don't really have that much experience with SQL-wise, so I'm not going to be able to compare that much. Let me be honest. But I think SQL Edge is going to be a little bit more, I think, advanced than SQLite. That's all I really can say.
Yeah, generally speaking, I would tend to agree. SQLite's really great for small scale embedded devices where I just need a database and don't have much RAM or much compute power or the ability to write to disk. So those are scenarios where that product really shines. You'll see it a lot on, say, Android devices um,
I
versus
know,
Azure. Oh, go ahead.
yeah. Say like, for example, I'm not sure SQLite has graph database tables. We have that in SQL Edge. You can run all kind of machine learning stuff. So there's a lot of kind of other, yeah, it's missing all kind of stuff, but it has some other neat features too.
Yeah. Um, One thing that came up is differences between what's in Azure SQL Edge and what's in the box product. In your trying out Azure SQL Edge, is there anything that's missing from it today that you really want to see?
Not really, because really where I'm right now is I'm going to be able to, as I said before, I'm going to write the .NET Core application. I'm going to create a container from it, and that thing is going to get some data from sensors and push data to SQL Server. So I just need like some update, insert statement, really like simple stuff. Maybe I can even use some graph database tables. But really, I didn't really need to do anything else because all of the other stuff like SSIS packages and other stuff, those are kind of available from the Azure side. As I said, there are some other kind of stuff you can just take the message you are sending and you can kind of process that there rather than you worry about trying to do that in a device.
Yeah, that makes sense. When I've been messing around with it, or there were a few things I looked at and said, "Oh, I hope that a future version gets this," but even then, it's still a pretty complete product as it is today, especially when you think about IoT scenarios.
Yeah, I mean, I agree because you don't want to go that much complex on IoT device either. And I think it really gives us a great kind of solution to be able to solve a lot of problems.
Right, right. Now, I do want to see Onyx models brought to the on-premises SQL Server. Being able to generate native scored predictions from neural networks has been something I've wanted for years, and that's in the IoT product. Hopefully, it comes over.
Sure, it might. I mean, I think it might when the IoT device. I'm sure they're going to get more powerful and powerful. So it might kind of develop with the devices together. So
Excellent. And if there are any questions from anybody else in chat, please feel free. Drop them in chat. I will pass them along here. We also had a little bit of conversation about SQL Server Compact Edition. And any thoughts on that versus SQL Edge?
I mean, not really. As I said before, I don't really have that much experience with those versions.
Okay.
Mostly, the full version. But as I said before, I'm not sure if those do they have like graph database tables and other stuff? I don't know. I guess that's a question for you.
Yeah, I'm not sure either. Good question. How heavily would you say Azure SQL Edge is being used in production?
Uh, as I said before, when I was kind of covering those IoT devices in history, I kind of try to show you the potential. Like we have like 50 billion devices out there, right? So the IoT Edge the SQL Edge just came out. So I'm not sure how much is there, but I think Microsoft is kind of in the right path out there to actually be able to get some of that 50 billion devices. Even they get like 5-10%, that's a huge amount of number of, I guess, licenses, right? So I don't really have a kind of number like that, but I can see that there's a new market for Microsoft, and that kind of now it makes more sense to me when the SQL Server 2017 came up for the Linux. I was trying to understand what was really happening here, but now they're pushing this in IoT devices on. It kind of makes sense now.
Yeah, yeah. And Anders also asked, what is the licensing model? I know you had a slide on it, and the licensing model is actually really good. I was shocked when I heard it the first time.
Try to find it here quickly. So as you can see, the pay as you go, $10, and if you have reserved, it gets cheaper. But I think that looks cheap if you have a couple of devices. But if you have like thousands, 10,000 devices, then I don't know, that might get a bit expensive too, I guess. But I mean, it's pretty good.
Yeah, I mean, considering you can have a fully fledged SQL Server instance for $60 a year.
Don't forget that 60 just SQL Edge, so you still need to pay for Azure IoT Hub on top of this for messages. On top of that, if you are doing other stuff like analyzing on cloud, so that I don't know. It looks like it's not just the SQL Edge, really.
True, true.
Yeah.
Also, I do want to point out that the licensing restrictions explicitly mention that this is for IoT scenarios. So even if you said, well, I could just run my production SQL Server instances on this thing, you can't just swap out to Azure SQL Edge. They don't do hardware limitations. So if you're messing around with it in an Ubuntu VM on a desktop, it'll run just fine. Just don't get caught with that in your server room as your production SQL Server.
Yeah.
Let's see. Could the Raspberry Pi run Azure SQL Edge standalone and not on IoT Edge?
I never tried it. I'm not sure.
I think the answer is yes. I think you can spin it up straight from the container, but that it wouldn't patch.
As long as we have, yeah, it says one CPU, 1 RAM, so I don't see why not.
Yeah, but so that's a really good question, IoT2Z. Maybe is the answer. So any plans for a free tier, Express/LocalDB?
Free tier, I'm not sure about it. I haven't really talked about it. On the free tier I know is in the Azure IoT Hub. So that's what I'm using the free tier here.
Yeah.
Azure SQL Edge, I don't know. I'll be surprised if they give something.
Right. Yeah, that's a good question, Solomon. I mean, licensing is always a Microsoft thing. They're quiet about it until they announce it. I would guess probably there probably won't be a free tier anytime soon, but considering that it's like $10 a month, uh, the Azure SQL Database basic tier is $5 a month. So they're probably kind of fitting that in the same area where, well, if you're just messing around with it for development purposes, it's $10 a month in Azure credits. Solomon does mention SQL CLR is missing from Edge. Yeah, that is a downside.
Yeah, that was a good amount of like from the database engine. It's missing a lot of stuff, so I couldn't really list everything here, but they have some good documentation there.
Yeah, and it does lead to interesting question about given pricing and limited features, how would it compare to a $100 Windows stick computer using Express or LocalDB? So a really low end. Actually, even the nukes are $200 or so. Um, but yeah, so there you go. Those are things that you can't do with the extremely cheap end SQL Server instance.
Sure.
There's a lot more to Edge though than just running a database. Yes.
It is. I mean, I think the SQL Edge is like really a piece of the bigger puzzle, right? You need the other puzzles pieces to make the really, I guess, a frame. So you still need Azure IoT Hub. Probably you're gonna need other products of Azure. So all of those needs to get kind of come together to be able to, I guess, give you a solution. So SQL Edge itself, yeah, it will store your data, but I don't know what are you going to do from that moment from the Raspberry Pi, for example, in my case.
Yeah. When I think about this, where this fits in the world, think of it as you have your IoT device and you're running a small application that needs a fairly powerful database. You're collecting a lot of sensor data, but you don't want to send up every message because it's really expensive. So you may average it over time. You may not even send messages as long as it's healthy, or you'll send like a message every few minutes that says, yep, still healthy, still healthy. But when there's a, say, anomalous value, which you can tell because you can run machine learning and generate predictions, then you could pass those messages up into Azure IoT Hub.
Yeah, the
Um,
other example they were giving, like for example, a jet engine, right? You have a bunch of sensors running in it, and you are flying, God knows where, and you can just put it out there. You can actually still get all the sensor results, and whenever you have the connection, you can just push them back, or even you can by using the machine learning, if something is going wrong, your device can actually do something about it without any kind of internet connection.
yep, absolutely. That's another really good example where you'll have intermittent online scenarios. So Anders wants to use it to migrate on-site databases at clients to Azure. That
You can
would,
try.
yeah. Though actually, I could see that being kind of an interesting thing where you almost turn it into an event-driven architecture,
Sure.
pushing data into a SQL server.
It might work.
There was a question from Viable Clan member: why the .001?
So they can make our life a little bit more difficult, I guess. It's much easier to say $10. When I look at that number, it's like, okay, $10 and what is that, 1 cent? I'm
ten
not sure.
dollars and 1/10 of a cent. Yeah.
Yeah,
I think that they just saw Office Space and they realized that if they get that 1/10 of a penny with every transaction.
that's right. That's right.
All right. Anybody else have questions for Hasan this evening? That's looking like it might be it. So thank you again so much for the presentation tonight. Appreciate the demo and appreciate everybody in chat who came in here. Session answered a lot of questions. Glad it was helpful for you. And with that, we're going to wrap up tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA subgroup. I do want to mention next Monday we've got Shop Talk. Next Tuesday we have our main meeting at 6:30 p.m. Eastern Time. And so we'll hope to see you at the next meeting. Until then, take care, everybody.
Thank you, everyone.